Okay, so we're going to go ahead and try to sketch a graph of this rational function. You'll notice that they've already factored it for us. And I said, oh, they probably won't leave it factored. Okay, well, let's find the y-intercept. Maybe I'll write my work over here. So my y-intercept is going to be at f of 0. If I put in 0, I'm going to get a negative 6 up in the numerator. And in the denominator, it looks like I'm going to get a negative 2. So I'm going to get 3. Now that's an ordered pair that I know then, 0, 3. Okay, so I want to keep that in mind. X-intercepts, that comes from when the numerator equals 0. So I'm going to have one at negative 2 and one at 3. So those come from the numerator. Those are going to be my x-intercepts. So now I know 2 more points. Okay, I don't have any graph paper, and the reason is because I don't know how big this is going to get, and so I like to try to kind of not limit myself, but I'll go ahead and draw 1, 2, 3, 4, 5. It looks like the numbers are fairly small. So I probably could have just used some a regular grid that I might have. Okay, so we did that. Okay, so now we want to talk about the multiplicities at the x-intercepts. So for this one, the multiplicity is 1. That means it's going to cross. And this has a multiplicity. I can write multiplicities. Well, I can't. There's not enough room. But this one has a multiplicity of 1, and so it's going to cross there. So that's helpful for us to know. Okay, now let's look at the vertical asymptotes. Vertical asymptotes come from the denominator. So we're going to have a vertical asymptote at x equals negative 1 and x equals 2. So I can put those in. I'm going to put those in right away. Vertical asymptote at negative 1 and a vertical asymptote at 2. I can go ahead and graph my points. 0, 3. That's right there. That's the y-intercept. And then I have a negative 2, 0, and I have a 3, 0. So those are my intercepts. Okay. So removable discontinuities. There aren't any. Nothing cancels here. So there's no removable discontinuities. So we don't get to do that, but that's okay. It's a fine example. And then we've got to do the horizontal asymptote. Okay, so now that we have to think about the degree a little bit. So for the horizontal asymptote, it looks like the degree of the numerator is going to be 2, because it's going to be x squared, and the degree of the denominator is going to be 3, because you're going to have an x squared times x, which is going to be x cubed. So we're going to have a y equals 0. It's not always y equals 0, but that's what we're getting a lot of today, I guess. Now the fact that we have 2 x-intercepts right on our horizontal asymptote, that's okay, because remember, it can cross. So, all right. Now, we're going to sketch now. Let's go to the middle part. Now, I'm going to say it's going to go something like, it's got to go through that point, something like that. Now, I know it should actually go through the y-intercept. Okay. How do I know that it's going to do something like that? Well, I know it has to approach the asymptotes. Like, why didn't I draw it upside down? Well, I can't cross the x-axis, because if I were going to cross the x-axis between those 2 asymptotes, there would have been more x-intercepts, and we don't have any x-intercepts in there. So that's the only way I can do it, because there are no x-intercepts in there, in that section between the 2 vertical asymptotes. So it has to look something like that. Now, I could plug in like the point 1 for x. I could plug that in and get a number, and that might help the graph a little bit, but I'm not going to, but you could. Okay. And then what's going to happen on the other two sides? Well, now let's go back to our vertical asymptotes. At x equals -1, they have to go in the same direction because it was squared. So whatever happens over there, I know this is going to go up this way. And then I also know it's got to hit that X-intercept right there. So I'm trying to draw it backwards here. And I also know it's going to cross. Now, I don't know what it's going to happen eventually. I don't know how far down it goes, but eventually it's going to start approaching that horizontal asymptote. So it probably doesn't go dip down quite that much, but that's just my graph there. So we've got our x-intercept. We knew it crossed at -2, and we knew it was going to approach that vertical asymptote going up toward infinity. Okay, then what happens at x equals 2? Well, at x equals 2, the degree here is 1, so I know it's got to go in opposite directions. So if it's going up on that side of the asymptote, it's got to be going down on that side of the asymptote. So I know it's going to come up, it's going to hit that. Oh, it's going to cross, isn't it? Okay. And then it's going to level out at some point toward the horizontal asymptote. So it's a very rough sketch, but it looks something like that. Both our x-intercepts had multiplicities where it was going to cross, so that should be reflected in the drawing as well. So they are a little bit of work to do. There's lots of things to consider, but that's how we graph a rational function.